Hi everybody. In this tutorial, which is the first of a little series, we're going to see how to control a basic synthesis process through bach.roll and bach.score. It's going to be a very basic tutorial, so I'll try not to give anything for granted. And by the way, it's my first video tutorial here. I really hope I'll get away with it. Let's start with a few basic concepts. Okay, so I just created a bach.roll object. I assume you know what it is since you're here, and I'm going to add a few notes. So once I locked my patch, I'm going to command click on some areas of my bach.roll object. If I were on a Windows machine, then it would be control click. In this way, I'm creating a few notes. If I had to be more specific, I would need to say I'm creating a few single note chords, but okay, we'll just ignore this subtlety for now. Let's say that I just created a few notes and I want to play them back. Okay, so I want to be able to start some kind of playback process, allowing me to hear what I wrote. Let's say that the first quick and dirty way to do this is through the bach.easy MIDI play abstraction, which is a very convenient one and one that allows you to get a simple MIDI playback of a bach.roll or a bach.score. So I need to connect it to the second from right outlet. Okay, now this is very important. It's the same in bach.roll and bach.score. It's the second from right outlet. Okay, and then I can just close, you see, lock my patch, select my bach.roll object, and play back the score. Pretty cool, but not too cool. By the way, I can also send a play message to the bach.roll object, which mostly amounts to the same thing. Okay, then I have a few more options with play and so on, but for now, let's say it's the same. But now I don't want just to get a MIDI playback of what I'm doing here. I actually want to drive a synthesis patch. Okay, so I'm going to get rid of this, and I need to figure out what actually comes out from this playout object. So I'm replacing bach.easyMIDI with a simple bach.print object. There you go. In case you have doubts about why is it bach.print and not just print, have a look to the tutorial that Daniele posted a few months ago, I think, about the out M, out N, and the basic formats of Bach messages, which, as you probably know, are called the LLLs in our jargon. Okay, so I just have to use Bach.print and not plain print. So I'm starting the playback again. I'm not hearing any sound now, but what's interesting here is that I'm getting a sequence of messages, okay, like this. And each of these messages gives me information about the content of the score and the modality of playback. So let's review them one by one. First, cursor 0. This one is telling me a playback is about to start, and it's going to start from position 0, so from the beginning of the score. Play. This means, okay, now the playback is actually starting. Okay. Then, note. Okay, I have 4 note messages. This is interesting, okay, because I have 4 notes. This is not coincidental, of course. So, let's see what we have in these note messages. First, a note router, as we call it. Okay, it's a header telling us that what's going to be played is actually a note. Okay, the following of this message contains specifications for a note, as opposed to, for example, a chord or a marker, which are other kinds of messages that you can get from bach.print during playback. Then I have one. One is the voice number. In this simple score, we only have one voice, but we might have more. So in this case, this number might be 2, 3, 4, 150, and so on. Okay, here it's one because it's our only voice. Then another one. What is this one? This is the MIDI channel. We have the option of assigning each voice a MIDI channel. I can right click on the clef. I get this contextual menu by which I can choose some details and properties of my voice, and MIDI channel can be set to any value from 1 to 16. 1 is good for now. Okay, by the way, I also have an attribute, which is MIDI channels controlling the exact same thing. Okay, I mean just an object attribute. Okay, one I can see in the inspector here. If I select the all tab here and type MIDI something, I get MIDI channels. And since I only have one voice, MIDI channels contains only the value 1. If I had two voices, this would be a 2-number list with one MIDI channel number per voice. Okay, back to the Max console. After the voice number and the MIDI channel number, I have a sublist. The first element of this sublist is an onset. What is the onset? It's the absolute position of each note or any other event in the score. It's its absolute position with respect to the beginning of the score, expressed in milliseconds. So this means that this first note happens 122 point blah 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 millisecond from the beginning of the score, and the second note, this one, happens 911 milliseconds from the beginning of the score. Okay, so it's not an inter-onset interval. Okay, it doesn't tell me how much time has passed since the previous note. It tells me how much time has passed since the beginning of the score. The second element of my sublist is the pitch of the note expressed in MIDI sense, which is one of the two basic ways to express pitches in Bach. The other is the actual pitch data type. So I could read C5 here, for example, or C6 in this specific case. Okay, but I'm not getting there now. Then maybe a further tutorial about pitches might be a nice idea, but for now, let's just stick to MIDI sense. Okay, so 7200 MIDI sense is the same as saying the MIDI pitch is 72. This is the note, okay, which means, well, if middle C is 60 and we have one MIDI pitch step for its semitone, this means that we are 12 semitones above middle C. That is, we are at the C above middle C. Okay, good. So the next piece of data we have is the duration of the note, once again in milliseconds. And then we have the velocity of the note. And of course, we can ignore the velocity, but it might be a nice idea, at least in some context, to keep it into account. And then we have these two zeros closing respectively each of the sublists we've encountered so far. These are the flags. It's an advanced thing. I don't think we're going there. Not for now, at least. Okay, so what if I want to play back this note through a synthesizer? Well, first, let's build a synthesizer. Let me switch off audio for now. Okay, and then we're going to switch it off later. So I need an oscillator first. Let's take, for example, rect tilde. Okay, which I kind of like. I like square waves. Rect tilde must send the signal to our audio output. So I'm adding a duck tilde object. And rect tilde for producing anything reasonably significant needs a frequency. Okay, so I need to tell it which frequency I want it to produce. Now, for example, 440. Okay, if I click this, I switch on my audio. Nice, I get my frequency. Okay, my middle A in this case. But I don't want to just type frequencies one by one. I want to retrieve them from the score, right? Where do I retrieve frequencies from? I'm going to retrieve them from here. Okay, this is the point we're going to retrieve our pitch and subsequently frequency from. Question: how do I get an element that is buried deep inside the list? Now I'm going to show you this. Let's take the list as it is. So I'm selecting its row, its line in the Max console. I'm copying it. I'm creating a Max message object. I'm pasting the message from the Max window into the Max message object. I'm going to get rid of the bach.print colon header, which is not an actual part of the message. And this is the, let's make it a bit bigger. And this is the actual textual representation of the note message. Okay, now the first thing I need to do is figuring out if it's actually a note or something else. For this, I can use the bach.keys object, and I give it note as an argument. Now you probably know bach.keys, but I want to review it just 1 second with you. Okay, if the LLL I'm inputting into bach.keys starts with note, now this is a slightly simplified view, but let's stick to this for now. Okay, if it starts with note, then it's going to return it without the note selector, okay, without the note router. And if it's not note, but it's something else, it's going to send me a bang from the rightmost outlet. Okay, so if it's foo bar, I'm not getting anything in the Max console, but I'm getting a bang here. Okay, so that's nice. So first thing I need to do is detecting whether it's a note or not. And by the way, strip away the note router. Okay, and then what do I get? Let's take the ozonebach.tree object and see what it looks like. Okay, so I'm getting this. Now, as we were saying, voice number, MIDI channel, sublist. Okay, and within the sublist, onset, sublist, and within this further sublist, MIDI sense, and blah, blah, blah. Okay, so I need to get the sublist that is the third element of the root level of the LLL. Okay, so I'm going to take some notes and write 3. Then within this sublist, I'm going to get the element that is at the second place. So I'm writing 2. And now I need, in the new sublist I've just entered, I need to retrieve the first element. So it's 1. So I've written the list 3, 2, 1. What does this list mean? What is this list? It's what we call the address of a specific element into an LLL. Okay, so 3, 2, 1 is the address, and it's a sort of path that I need to do, that I need to walk to retrieve the element I'm looking for. So 3 means 1, 2, 3. 2 means, okay, go one level deeper and get 1, 2, and 1 means go one level deeper and get 7200. So now I want to play back the actual MIDI sense values from my score. So I need to replicate this in a way. So first I need the bach.keys note object. Okay, to select the note LLLs and get rid of the others, and also get rid of the initial note router. And then I need to retrieve the element that is at address 321. So this one. Okay. Now, even if it's just a single element, this one is going to return the native format LLL. Okay, so I need at out M. Now, as you will see, I will start the playback and I get the MIDI sense value in real time. Now that's good. Now what follows is relatively easy. So I need to take this one, divide it by 100 so as to get the MIDI pitch values as opposed to the MIDI sense values. I need to convert them to frequency. So MIDI to frequency, and to send the corresponding value to rect tilde. Okay, this is our first really basic and not so satisfying synthesizer. What is the major flaws of this synthesizer, even before playing it? Is the fact that there is no notion of the duration of a note. Okay, so once it hits a note, it's going to play it back forever. Now I'm going to switch on the audio. By the way, rect tilde is about to play again the 440 frequency that I had introduced before, but if I hadn't, it would be playing at 0 hertz frequency, which would be even more annoying. So that's fine. Now 440 hertz, and then I'm going to click play and you will hear our amazing soaring melody. Okay, 440 hertz, as we were saying, go. Okay, and it never stops. I need to stop it by switching off the audio. Fine. So that's a start, but of course we need to go further than this. Okay, now we could say, okay, I want to retrieve the position of the onset and use it for example, controlling an envelope generator. That's totally possible, but there is one nice thing that I want to show you now. It's a very convenient object that is going to help a lot in this kind of scenario. The object is called bach.playKeys. Now watch out, I'm typing bach.playKeys and I'm not finalizing the object, okay? Because bach.playKeys, if I do so, I get an orange, okay, or brown, I don't know which color is this. I get a brown object and an error message. Okay, good. So what do I need to do? I need to type bach.playKeys space, and then one or more symbolic names referring to the actual elements that I want to retrieve from my note list. Okay, so bach.playKeys, for example, what do I want now? I want the sense at out M, as usual. And this sort of replaces these two boxes, but does it in a more semantical way. So it's much better. I don't have to remember all the time which is the exact position or of one or another parameter of my note. Okay, they're just there. Let's try it now. Yay, it works. Cool. Now, as we were saying, I'm allowed to have more than just one symbolic name, not more than just one key. So for example, I can write bach.playKeys sense duration. Okay, and guess what? I get another outlet, and from this outlet I get the duration of each note. Okay, now it's not going to be very expressive now, but if I change the durations by shift clicking, so I don't move the, sorry, I didn't want to do this, so that I don't move the duration line up and down. Okay, and as you can see, from each note I'm going to retrieve its duration. Now I'm not going to switch on the audio, but you're going to see what happens here. Okay, so each note's individual duration. Okay, and how do I use this duration? I just use it for controlling a very basic envelope. So I want a short fade in so as to avoid clicks. And I want a short fade out. By short, I mean just a few milliseconds. And I want a longish sustained phase. How long? Well, the exact duration of the note. So that's exactly the point. So as you can see, now I can do something like this. So I'm going to use line tilde. And here I need to format a message for line tilde. So I'm going to tell the guy, go to 1 in 5 milliseconds. Stay at 1 for $1 millisecond. And go to 0 in 5 milliseconds. I assume you're familiar with the $1 syntax of max. If you're not, it's just a placeholder for whatever value enters the message box from its inlet. Okay, I'm going to connect this to line tilde, and of course, if I need to produce an envelope, I need to do it like this. Okay, so this is going to be the way I apply my amplitude envelope to the square wave I'm producing. Now I can switch on the audio without getting any disturbing sound left over from the previous playback. And as we shall see, the duration of its note will last exactly the written amount of time. Okay, now it starts to get better. Of course, it's probably not ready yet for composing the next masterpiece of computer music, but it already, let's say, it already starts to make sense. This is where we're going to stop now, but I would like to point out the two main things we need to address as soon as possible. So the first one is this system is not polyphonic. It means that if I do something like this or like this, it's only going to play one note at a time. Okay, so no way to get more than one note at a time. For addressing this, we're going to use, well, we're going to look at two strategies, basically. So we're going to do it with polytilde, and we're going to do it with the brand new MC objects from Max 8. And the other thing it completely needs is some kind of timbral or, dynamic or whatever control on the actual synthesis sounds we're producing. Generally speaking, of course, the interest of synthesis is in the versatility of the process and the fact that virtually every parameter of the sound production can be controlled over time. So it's not so interesting to have a single waveform synthesizer with no possibility to alter the quality of the sound. This is what we're going to do very soon. So actually, the next session of this tutorial will be about slots that are a powerful construct to embed into a score virtually any kind of additional information about the features of the playback. But for now, I'd say that's it. I hope you enjoyed it and see you next time. Bye bye.